Hello, Chemistry 10H students. This is Mrs. Altman. In this video, we're going to be discussing naming compounds that contain polyatomic ions. So a polyatomic ion, this is a group of covalently bonded atoms that have a charge that is not zero. So I'm going to draw one out. I'm never going to specifically ask, well, I'm not for this chapter going to ask for you to draw it. I just wanted you to have seen it once. So I'm going to take the polyatomic ion phosphate, which is PO4 with a 3- charge. So what this actually looks like, these single lines are representing covalent bonds. The dots are representing non-bonding electrons. And the circles with the minuses in them, they're representing negative charges. So notice I have 1, 2, 3 negative charge, and it says 3- up there, but it's by and large covalently bonded. So truth be told, you don't really need to be able to visualize that to be able to do these problems. I just wanted you to have seen it so you know where this comes from. And then you should have your polyatomic ion sheet, which is just a list of formulas and names with you as we go through this video. So when you are naming compounds with polyatomic ions, you are first going to determine if it is type 1 or type 2. So the way that you determine that is just by seeing if the first element is a transition metal. If so, it is type 2. Otherwise, if it contains a polyatomic ion, it is type 1. Otherwise, you're going to follow the same naming conventions as we've been doing. Just instead of, say, having chloride, you will just use the name of the polyatomic ion. You don't need to change any sort of suffixes. That's already done for you from that sheet. Let's take a look at an example. So I've got iron 3 nitrate. So this is type 2. So I've got iron with a 3+ charge. I go to my polyatomic ion sheet, I find nitrate, which is NO3 minus, and I crisscross. So I have Fe, I don't have to write the 1, and then parentheses, NO3, 3. So anytime you're putting a number on the outside of a polyatomic ion that is not 1, you must use parentheses. I'll write that down. The reason why you have to do that is because otherwise that 3 would only apply to the oxygen and not the nitrogen, and we want it to apply to both. For the next one, I have hydronium sulfide. Hydronium is a polyatomic ion, H3O+. And then I've got sulfide, so 2-. So I'm just going to be crisscrossing here. I have to put H3O in parentheses. So H3O 2S, and I'll type that so it looks a little neater. And then I've got sodium peroxide. So I've got Na+. Peroxide is from the polyatomic ion sheet, O2, 2-. So I bring this down, and I get Na2, O2. And some of you are thinking I should simplify this. The reason why you don't simplify it is because that 2 right here, that's from the formula from the polyatomic ion. We're only going to simplify with things that are outside of parentheses with polyatomic ions. I'll write that down. So I'll give you an example of something I could simplify with. So for example, if I had, let's go with calcium sulfate. So I'm going to go a little bit off of the script here for a second. Ca2+, SO4, 2-. You would originally get Ca2, SO4, 2. but it is obligatory to simplify it to just be CaSO4. All right, so back on the script then. Copper 2 hydroxide. So it is copper, so Cu, the 2 plus means I give it a 2 plus charge. Hydroxide, that is a polyatomic ion, OH minus. I have to use parentheses here because OH is from a polyatomic ion. And then silver 1 acetate, so Ag with a +1 charge. Acetate, which is C2H3O2 minus. It's just 1 and 1, so I don't have to do any parentheses or anything like that. So just AgC2H3O2. I think your polyatomic ion sheet rates acetate 2 ways, so I'm using the first way, but if you did it the second way, that would have been fine. So you could have also said AgCH3 COO. That's also correct either way. I just prefer the first way, but it's just a better personal preference. You could do the second way if you'd like. All right, now let's look at the opposite of it, which can be a little bit trickier. So for the first one, the NaC2H3O2, first thing I see is that this is type 1. So I know that because the first thing is sodium. So I don't need any Roman numerals, so it's just sodium. I find C2H3O2 on the polyatomic ion sheet. It's acetate, sodium, acetate. For the second one, and I'll actually put the formulas up top such that you know which one goes with which. For the next one, I've got NH4Cl. So this is type 1 because it contains polyatomic ion and also because it doesn't contain a transition metal. I find on the polyatomic ion sheet that NH4 is ammonium, and then it's chloride. I have to change the suffix of chlorine to IDE because it is an anion. Next, I have CuSO4. This is type 2. So I know it's going to be copper something, and then SO4 is sulfate. I know that from the polyatomic ion sheet. And now to figure out the charge, I'll show you sort of like a trick. It's very similar to what we did for the last video. Right, so what I do, it's again very similar. I'm going to be listing the charges and how many of them I have. But with polyatomic ions, just put them in parentheses if they're not already, and just put a 1 on the outside if there's nothing there already. I don't know what the charge of copper is. Sulfate has a charge of 2 minus, and then otherwise it works the same as before. So 1 times x plus 1 times -2 is equal to 0. X is equal to +2. So it is copper 2 sulfate. We have something similar now, CO2SO4. This is also type 2 because copper is a transition metal, but I have to figure out what the charge is. I do the same process that I just did. So because there weren't parentheses around sulfate, I put it in parentheses just to remind myself that that 4 is a part of the formula of sulfate and not that I have 4 of them. So 2 times x plus 1 times -2 is equal to 0. I end up getting the x is equal to +1. So this one is copper 1 sulfate. So the difference between CuSO4 and CO2SO4 is just the Roman numeral. Next I have Fe C2H3O2 3. So this is type 2 because iron is a transition metal. I'm going to need to figure out what the charge is. So the charge of iron, I'm just going to say that it's X because I'm going to figure out what it is. C2H3O2, I go to my polyatomic ion sheet, I find it, I see it as acetate, and its charge is -1. So 1 times X plus 3 times -1 is equal to 0. X is equal to +3. So this is iron 3, because that's what I just got for my answer. And then C2H3O2 is acetate. And then I have SrNO3 2. This is type 1 because strontium is not a transition metal. So just strontium. I find NO3 on the polyatomic ion sheet. I see that it's nitrate, strontium nitrate. I do not need Roman numerals unless I have a transition metal as my first element. Right, that is all for today's video. Thank you so much for watching and have a great night.